Hello everyone, this is Mr. Molo for lesson 7-3, special products of polynomials. So this is very similar to yesterday's lesson. In fact, I think this one's kind of easier. You'll notice that most of the problems again are set up with two parentheses and then an x or a y or some variable and then a number, except you'll notice these are special. So, and the reason that they're called special products is because usually they're going to be pretty much the same in each set of parentheses, x plus 2, x minus 2. 2x minus 1, 2x plus 1. So the process doesn't change at all. You can either still use the algebra tiles, you can do the FOIL method, or you can do my favorite and use the Punnett squares. Otherwise, it doesn't really matter. It's just going to look like that. Some of the problems might even be exactly the same, and they might even have this x plus 2 here. So that really means x plus 2 squared is x plus 2 and x plus 2. So that means you just put an x plus 2 up here and then an x plus 2 over here. Otherwise, then the process kind of stays the same. X and x is x squared, x and 2 is 2x, 2 and x is 2x, and 2 and 2 is 4. And then remember, if you do it correctly, you should be able to combine those two. So x squared plus 4x plus 4. So again, not really anything super different from yesterday, just kind of all of them have special products. So let's look at some more examples. Okay, so here we have a plus 3 squared. So I'm going to make my Punnett square here and do a and 3 and a and 3. So a and a is a squared, a and 3 is 3a, 3 and a is 3a, and 3 and 3 is 9. Combine these two, so you get a squared plus 6a plus 9. So pretty much just like yesterday's. Might want to be careful on some of these that have negatives, because now it's a -2 and a -2. So b squared and b, or b and b is b squared. b and -2 is -2b. -2 and b is -2b. Then -2 and -2 is a +4. So b squared minus 4b plus 4. Okay. Otherwise, some of these other ones, now you have 2x plus 1 instead of just like the first couple ones. So if I look at number 4 here, I'm going to put in a -2x plus 1 and a -2x and a +1. So -2x and -2x is 4x squared. -2x times 1 is -2x. 1 times -2x is -2x, and 1 is 1. Add my like terms, so I'm left with -4x squared minus 4x plus 1. Okay, and then it gets a little more complicated here with these other ones because now they're throwing in two variables at you, but realistically it's the same process. 3x plus 2y, 3x plus 2y. So 3x and 3x make 9x squared. 3x and 2y make 6xy. Remember to go to alphabetical order there. 2y and 3x make 6xy. And then 2y and 2y make 4y squared. So a little different there with two of them being squared. And then remember to put it in the correct form. We go by the exponent of the x first. So this one's going to go first because it's x squared. 6xy and 6xy make 12xy. That one goes second because it's still x to the first power. And then 4y squared goes last because it doesn't even have an x. So this would be how we would write it properly in our book. And then kind of the same thing with 8 and 9. Put the A before the B. Same thing with 9. Put the C before the D. So make sure it's in alphabetical order. Some of these at the bottom get kind of weird just because of what's going to happen when we try and combine. So let me put x minus 3 and x plus 3. So x and x make x squared, and x and -3 make -3x. 3 and x make +3x, and 3 and -3 make -9. So when you look and you try and combine here, -3x plus 3x is 0, so it just goes away. So you'll notice on all of these questions, 10, 11, 12, that's what I mean by all of them, not all of them in the homework, but all of these are going to have these ones where they're going to eliminate in the middle. And it tries to kind of teach you some cheat tricks here on page 216, but I don't think it saves us that much time, so I just personally just do the problem anyway. But there's some cheat trick there where they use the A and the B, and they kind of just explain like, hey, this is what happens for problems that look like 10, 11, 12, where you're still going to multiply the first two and and the last two, but then the middle ones are kind of going to go away because one's going to be positive and one's going to be negative. Okay. Otherwise, on the back page of the note packet here, it's pretty much the same kind of a thing. Some of these just are more complex. They have fractions. Otherwise, it doesn't really change. Let's look at one of these on here. Let's look at number 17. That one looks probably the most difficult there. So I got negative 3j minus 2k, negative 3j plus 2k. So again, I see the same thing, negative 3j minus 2k, negative 3j plus 2k, so I can assume those middle ones are going to cancel out because one's a positive, one's a negative. So let's do the math. So negative 3j times negative 3j is positive 9j squared. Negative 3 times a negative 2 is a positive 6jk. Negative 2 times a negative, positive 2 times a negative 3j is a negative 6jk. And then negative 2k times positive 2k is negative 4k squared. Again, when I try and combine these middle two, they cross out. Positive 6 and negative 6 are 0. So I'm just left with 9j squared minus 4k squared. All right. And then 19 through 24 here, they're just trying to help you figure out a way to multiply these numbers easier. So most of you would probably grab a calculator for this, but there's kind of a simpler way to do it, and I'll kind of talk about this more in class. So instead of using 18 and 22, I mean, I wouldn't multiply 18 times 22 in my head, but I could multiply numbers like 20 and 20, and they're really close to each other. So if I do 20 minus 2 times 20 plus 2, really 20 minus 2 is 18, 20 plus 2 is 22, so I just kind of wrote it a little differently. So that's kind of the same as 20 squared minus 2 squared. 20 squared is 400, 2 squared is 4, and that gives us 396. And if you take 18 times 22 in your calculator, you'll figure out that it's 396. So just kind of a different way to multiply some of these numbers. So 49 times 51, you could do 50 minus 1, that gives us 49. And then times 50 plus 1, that gives us 51. And that's really the same as 50 squared minus 1 squared. 50 squared is 2,500. 1 squared is 1. So that gives us 2,499. Okay, and then you can kind of do the same thing here. 31 squared is really the same as 30 plus 1 and 30 plus 1. So same thing. So 30 times 30 is 900. And now here when you multiply these, there's my 900. And now 30 times 1 is 30. 30 times 1 is 30. 1 times 1 is 1. So 900 plus 30 plus 30 plus 1 is 961. So just a different way to do multiplication. Otherwise, if you have a calculator, you can just do 31 squared and do it. But it might help some of you to think differently about multiplying if you think of it like this, and could probably do bigger multiplication in your head if you can just do this.